Good morning everyone. Welcome to the course Stability Aspects of Structural Steel Design, Concepts and Applications. In this class, let's talk about the introduction to stability. Before we talk about stability, we should wonder why one should study the concept of stability. Let us look at some pictures here. The picture that you see here is basically a crane that is used to lift a car from a water body. So a crane is engaged to take out a car fallen inside a water body. And you can see that the crane is doing a pretty good job lifting the car, and it is slowly taking the car up from the water body, and it is almost there. Just before the car is taken outside the water body, the entire crane is toppled. As you can see, a pretty nasty picture there, and the entire crane is now inside the water body. Now one would wonder, what is the reason for this one? Is the crane capacity insufficient to lift the vehicle? And that's probably what the people who are involved in the operations thought so. Let us retry with a new crane of higher capacity. So they came up with the jumbo crane. As you can see here, the rescue operation is continued with a different crane of higher capacity. As you can see that the crane is doing a pretty good job. It is not only lifting the car but also the fallen crane inside. So it is lifting both of them simultaneously. And then you look at that, the same crane, which is a jumbo crane, again is fallen into the water body. So the new crane of higher capacity could not also safely take out the vehicles. So this tells us that the strength is not important, whereas stability is important. So somebody did not take into consideration the overall turning stability of the vehicles and considered only the strength as an important factor. This is a great lesson for all of us, that sometimes stability of a structure plays a vital role compared to strength. Now let us understand the importance of stability through a few more case studies. The classic example that comes to my mind is the Ronan Point collapse. The Ronan Point is a multi-storied building in East London, UK, constructed in 1968. Here the collapse was triggered by a gas explosion on the 18th floor of the residential tower. A lady woke up in the morning, she wanted to make a cup of tea and she went inside the kitchen. She on the gas with a lighter and there was a big explosion. The explosion blew out a load-bearing wall on the 18th floor of the tower, which led to progressive collapse. So basically the load of the 18th floor came to the 17th floor, which caused the collapse of the 17th floor. And the 17th floor plus the 18th floor caused the collapse of 16th floor and so on and so forth, leading to a progressive collapse. So the catastrophic failure brought down one whole corner of the building. This disaster resulted in the death of 4 people and injury to 17 others. The reason is the lack of adequate structural redundancy, which means that there are no alternate load paths, leading to progressive collapse after the explosion. Now let us look at another example of a stability failure, which is the Hyatt Regency Skywalk collapse. This happened in 1981 in Kansas City, Missouri. There was a huge dance party that was going on. Between 1,500 to 2,000 people were in attendance at the tea dance when the skywalk collapsed. Suddenly, without any warning, the 4th floor skywalk collapsed onto the 2nd floor skywalk directly below. Both skywalks then plunged onto the crowded lobby floor. The collapse caused the death of 114 people and injury of more than 180. The reason is inadequately designed hanger to rod box beam connection detail. Let us look at what is the connection detail in the next slide. So we can see that there is an original detail that is given on the picture on the right hand side, where the rod is continuous, and then there is an as-built structure or connection detail, as you can see on the left hand side. You can see that the rod is broken into 2 halves and they are connected at that location by means of nuts and bolts rather than having a continuous rod. The hanger rod to box beam connection detail did not satisfy the requirements of the 1969 American Institute of Steel Construction provisions. So instead of a single rod passing through both the skywalks, separate rods were used, doubling the load on the 4th floor connectors. Basically the boundary condition in the original detail is continuous, so it is acting more like a fixed condition at that location, whereas in the as-built construction, they have chopped it into 2 pieces, basically altering the boundary conditions from a fixed condition to a simply supported condition, causing the load to double at that location. The next example is the stability failure of a I-35 Minnesota bridge collapse. Here you can see that a 1900-foot long bridge constructed in 1967 collapsed during the rush hour traffic over the Mississippi River. An investigation by NTSB, which is National Transportation Safety Board in the US, revealed that there was a crucial design flaw that was present since the bridge was built. The gusset plates were found to be undersized. So the reason here is the combination of undersized gusset plates and added weight from the construction load caused the bridge to buckle and collapse, as concluded by NTSB. This collapse resulted in the death of 13 people and injury of 145 people. From this example, as well as the previous example from the walkway collapse, we can understand that the devil is in the details. If you don't design the connections properly or you don't build the connections properly, then there is disaster that is waiting to happen. Another example of a stability failure is the Lambian's Plaza collapse. This occurred in 1987 at Bridgeport, Connecticut. A 16-story residential building collapsed during construction, killing 28 workers. The reason is the inadequately designed temporary supports during the construction process. The failure happened in less than 20 seconds. There are several other examples in the history. The one on the left side is the Tay Bridge collapse in 1879. The bridge was nearly 2 miles long and used to be the longest railway bridge in the world at that time. The bridge collapsed under a stormy wind along with a train running over the central span. In the right side is the famous Tacoma Narrows Bridge collapse that happened in 1940. On November 7, 1940, only 4 months after its grand opening, the bridge swaying turned deadly. The bridge was unserviceable from that moment, and luckily no human lives were lost. All these failure case studies indicate to us that the primary aim of the structural calculations is to produce a safe and a strong structure. A strong structure does not necessarily lead to a safe structure. In order for the structure to be safe, we need to take into consideration the stability aspects of the structure as well. With this one, we complete the introduction part of this course. Thank you very much.